Okay, so we're going to go and start our tutorial for aerofoil simulation using Fusion 360 and Autodesk CFD. So to begin, we'll be learning the basics of setting up a CFD simulation. We're going to learn how to apply different material settings to our glider once it's in our simulation software. We're going to determine the test conditions for our simulation. So we're going to set up airspeed and air pressure properties for our simulation. We're going to use graphic analysis tools like global pressure, tracers, and planes to do some further analysis of our simulation to test for viability of our aerofoil. And we're going to learn how to calculate the forces present in our simulation as well. Some of the tools we'll be using are Simulate and Simplify, which is a Fusion 360 process. We're going to use calculate an external volume or build an external volume once we're in CFD. We're going to define solids and fluids and different types of solids, such as plastic and wood and polystyrene. We're going to also set boundary conditions, which is our airspeed and air pressure that I mentioned before. Some of our processes that we'll be looking at, we're going to set global pressure, so we can visualize the air pressure on the surface of our glider. We're going to use the planes tool to check air velocity around our glider as well, and we'll use that to check in with Bernoulli's principle and really see firsthand the relationship between airspeed and air pressure. We're also going to use tracers to check for laminar or turbulent airflow, and we'll be using a wall calculator finally to determine the force in newtons acting on our glider while it's in the simulation. So in terms of success criteria, you'll be able to determine the effectiveness of your glider using the simulation. So you'll be able to determine, hopefully, that it will fly. You'll be able to generate the total forces acting on your glider in each dimension. So in the Y and the Z dimension is what we're really looking at. And that force will be generated in newtons using the wall calculation tool. And finally, you'll be able to use this to compare the effectiveness between different glider iterations that you make, because you'll be making a number of different iterations with the goal of improving your glider. Okay, so we're going to start in Fusion. And one thing I've done here before I leave Fusion and go to CFD is we've calculated a center of mass. So if you look here, you can actually see that little dot as the center of mass there. And our overall objective for flight stability is to make sure that our center of lift is above our center of mass. That will create stable flight. Okay. One thing we could do if, say, this glider wasn't stable in flight is you could move up the sketches here and here in little increments to just make this angle of the pitch of the wings going out a little bit higher. Okay, so to first start your simulation, you'll need to go to the Design tab up in the top left corner, and you'll need to click on the Simulation menu. If you have CFD properly properly installed, you'll get this button here, Simplify Geometry for use in simulation. And all you need to do is go Simplify Model. Once you've done that, you'll get a number of menus pop up here for you. And what you want to go to is Tools. And then with CFD installed, you'll click on this CFD button. What you'll need to do here is start a new design study. If you do have an existing design study, there should be a list of design studies that you've already completed. But I'm going to start a new one for the purposes of this tutorial. So mine is saved in a CAD simulation folder, and I'll open that and it'll create its own directory there, and I'll go launch. Okay, so CFD will spin up and open in a few seconds, and then it'll ask me a number of other questions. So you can see here, computing the model, making sure it's okay. It'll do a full check of your model and it'll let you know if there's any issues. So this is the first menu that will pop up called Geometry Tools. You can always just click back here in this area to go back to Geometry Tools. And really you just want to follow the guidance that's offered to you. So here we want to merge edges. And you can actually take down the tolerance of this. You can press it multiple times as well if you're having trouble with certain things. You can go, then after that, go to Small Object and go Remove Edges there. Between those two things, you should have a fairly stable simulation model. Finally, we're going to go to External Volume. And if you have a look at the board now, guys, you'll see that the pink volume around our glider is that external volume I was talking about. And what we'll do is we'll kind of eyeball it and stretch it out to a point where we're happy with it. And I'm just going to use these arrows to do that to start with. You can, of course, do this numerically as well. Okay, and I always look from the side to check if I've got enough space. What you want is a bit of space in front of your glider, but more behind, because things like traces and drag, a lot of the interesting stuff happens behind the glider after it passes through the air. All right, so I'm going to go right plane, I'll go front plane, and then I'm just going to do some fine tuning. So my X offset will be 0, my Y offset will be 10. I usually just round it up. My Z offset, if I put it to 0, it tends to put it towards the top, so I might make that 1. That's good. X length, I'll make that 45. Y length, I'll make 80. And Z length, I'll make 20. All right, I'm fairly happy with that. You can take those numbers and put them straight into your external volume if you want to. You can also calculate angles. I haven't really played with this too much, but that might be something useful to you as you start to iterate. One thing you always have to do, don't hit close, always go create. And after that happens, you'll just get a big silver looking block. And this can be a little bit confusing because you're not really sure what to do with what you have. I'm going to change my output bar. We're not going to need that until we actually start our simulation, just save a bit more area. So my first job here is I always know what to do next because I follow this menu down. So material here, boundary conditions. We don't touch initial conditions or mesh size. We don't touch motion. We don't touch groups, but we do, after we do all this, we go to solve. So all we really need to interact with is material and boundary conditions, and then we can solve our simulation. Okay, so I'm going to go through and define different material characteristics for each volume present in this model. So I'm going to right-click. So this CFD created volume is the block of air that we just spoke about. Every time you select something, it highlights in pink. So right-click, edit, and it'll default to fluid as a type of material and air. So for the purposes of this simulation and also in aeronautical engineering, air is termed as a fluid. So we're going to apply this, and you'll notice it changed color. You still won't be able to see your glider, but if you want to, right-click on your volume and you can change the way it's displayed. So it can be shaded, which is what's here. It can be an outline or transparent. I'm going to choose transparent, and you can see our glider in the middle there. Now, what I need to do is go through each of the other materials and define materials for those as well. So our nose cone and our tail fin, these are all different parts of the tail fin, different parts of the body. I'm going to control select all of those. I'm going to right click and go edit. And these parts of the tail fin are a solid, and that solid will be, in our case it's PLA, but ABS is very similar. So I'm going to set these as ABS. And that'll be color coded in red down the bottom. And if you zoom in, you can see those parts now in red. Okay, so I've still got some unassigned volumes here, the fuselage and the wing. So the fuselage I'll edit and define as a solid again, and I will make that softwood because we're using balsa. Okay, and then finally the wing, I'll right click on that, edit, that is a solid, and I'll go down to polystyrene. This list is organized alphabetically, so you'll need to scroll down to P if you haven't done this before, but after you select a few materials, it'll put those to the top. So I'll apply that. So we've got polystyrene in pink, air in light blue, wood in brown, and ABS in red. So we're done with our materials. Everything here has a material assigned to it, and there's no unassigned materials in our simulation. So next, we're going to go to boundary conditions. So you can see that here, or you can see that here. So I've got materials, to boundary conditions, and after this, we're going to go to solve. So boundary conditions. You can see here, now that we've switched over to boundary conditions mode, every boundary of this external volume highlights when I mouse over it. So here, I'm going to click on this external volume, go edit, and it defaults to velocity. So in meters a second, I'm going to set this to 10. But as we do more testing of our gliders, we'll be able to really make a finely tuned value for our velocity magnitude. I'm going to apply this value of 10, and you can see this black stripe here indicating that there's a boundary condition on that boundary. So air is pushing out here at 10 meters a second, but where does it go? So what we need to do here is define the rear boundary as having a pressure of 0, okay? So it works like a vacuum. Anything that's pushed out from the front boundary will get sucked up by the back boundary, okay? So no resistance there. All the other boundaries we don't need to bother with, okay? So after doing that, my simulation is pretty much ready to go. I've only assigned materials and set boundary conditions. When you're ready and you're fairly confident it's working, you should see a black stripe at the front and an orange stripe at the back. You should see all of your parts of your glider with assigned materials. You can click this button here, Solve. All right, and there's a few things we need to put in at this point. So under these 3 tabs, we won't deal with adaptation, but we will put in values to control and physics. So here, what I generally do is 150 iterations. So this is a machine learning program, essentially an AI program that will iterate and re-simulate and learn from the conditions that you've inputted into the simulation, okay? So what you need to do here is 100 to 150 iterations, and my computer should be your processor. Under physics, because we're dealing with air is a compressible fluid, so we're going to change incompressible to compressible. And we don't need to mess with any other settings here as well. After that, we are going to click Solve. And you'll see our message window come up. And this is the point where you'll know if there's anything wrong with your geometry that you've imported to CFD. I know I've done this before, so I know there shouldn't be any issues with it. Okay, it can take some time. We'll get to the start of the simulation and then we'll hit pause. Once we see this area down here, the convergence plot, once we see that starting to generate, I'll pause the recording and then we'll come back when that's all done. I might even pause now and unpause once the convergence plot is started. Okay, and what we can see here is the start of our simulation running. And one thing I like to do while I see this convergence plot generating is to turn on my global pressure results. So what I do is I actually turn off the visualization of air. And you can actually look at your glider straight away. So right now, there's not much to look at. And I'll switch this over. One other thing you have to do to look at global pressure is change it to static pressure. And you'll start to see a little bit more color pop up. So what you'll see in this convergence plot is the calculation of various, physical data points here. So you'll see the velocity in each of the 3 dimensions. You'll see pressure. And the rest we don't really deal with. Yeah, I can't see any. So it's just these ones, pressure, and then the 3 velocities. I can see 1, 2, 3, 4. Yeah. So what you'll see happen is this convergence plot will build, and it'll look quite erratic at the start. But then as the iterations build up, you'll see the convergence plot start to level out. And you'll also see that reflected in the simulation. So here you can see as the iteration moves up a notch, you'll see it start to just work out what's happening just that little bit more. Okay, and it'll get to a certain point when you'll start to see some data you can use. One thing I'll also do is go to my view and I'll turn off this axis here, local coordinate axis. Just makes it a bit more clear. All right, so I'll pause now and we'll come back to it when it's gone along a little bit. Hi there everyone and welcome back. And so our convergence plot has just finished. So you can see here that at the start we have some pretty kind of erratic graphing, and then as this kind of passes through different iterations, it starts to stabilize, around here, like just a bit before 75, so around 70 or 60 iterations, it starts to stabilize. And here we can see that it's all fairly stable in the different things that it's calculating, so maybe some minor changes there. But for our purposes right now, 150 iterations is absolutely fine. And you can see here the global pressure map that we've turned on as we were calculating is all done here. So that's our first indicator to how our glider is working. So if we're going off Bernoulli's principle, we can see here this is static pressure in dynes, and on top of our wing here we can see that band of low pressure, then equalizing as it gets towards the back of the wing, and then underneath we can also see a band of higher pressure as well. We don't want to see too much of a difference here. We don't want really high levels of pressure underneath our wing. Remember, our goal here is to find equilibrium, so it floats through the air rather than just creates the most lift possible. Anyway, so now what I'm going to do is take you through some of the tools we use to do some more analysis. So this is the first one, obviously, the global pressure map. And I can keep this up while I engage the other tools that we need as well. So I'm going to go up here to results, so this little tab up here, and we have a few different things that we can use. So mainly we're going to use this tool here, planes and traces, and then finally we're going to use wall calculator, okay? So here I'm going to go to planes, and I'm going to go to this toolbar across the top, and I'm going to go add, and it will be set to velocity magnitude. Okay. Now it'll look a bit funny to begin with because for my global pressure result, I had my air turned off for visualization. So if I turn it back on, we can see a lot more data about this. So to move this map around, to move this plane around, you just grab these tabs here. You can actually rotate it and everything if you want to as well. But really what we're looking at for this part is looking at how much drag we're producing here. Okay, so we're looking at velocity of air. And if you're talking about it in terms of colors, what we want to see, we've got this really tiny little pocket of blue, kind of really, stationary air. We want to minimize that as much as possible, okay? So you can see that here, that we've got really nice, smooth laminar airflow around the wing, and then we just have this little pocket of drag at the back. And now this might be something you want to adapt in your following iterations to try and design out of your designs. But yeah, so that's one thing I can see. And what this is telling me is I've got higher pressure above the wing than below the wing because I've got higher airspeed here and slightly lower airspeed here. And that maps back to what we're seeing for our model, right? So if I go back and go back to global, I should be able to see my model as well. CFD created volume. Sometimes it kind of does funny things with changing the shading and everything like that. So what I have to do here is change all of this back to shaded, including the polystyrene wing. Okay, so you might just have to right click and just make sure it's displaying in the way that you want. Not sure why it did that, but anyway. So now we can see here, when we look from the top, that this band of low pressure is directly correlating to this area of high air velocity. So you can really see Bernoulli's principle visualized there. And also to back that up further, to see that this glider will hopefully fly, we're seeing more air velocity on top, higher air velocity on top than we are underneath. We're also noticing this pocket of air being dragged along with our glider as the wings fly through the air. So some adaptations I might want to make from here, depending on my results, is maybe changing this angle of attack up by 1 or 2 degrees. Okay. All right, so what I'm going to do next is turn off planes, and I'm going to show you the next tool that we can use called traces, and traces is just up here. So I'm going to go to traces, and I'm going to go over here. What I find works really well is just adding little lines of traces. So here, line, I'll go add, and I usually go from the middle out, so I'll click once. I'm not dragging, I'm just moving my mouse down, and I'm clicking again when I'm happy. Okay, I'll go add again, and click another one down as well. And you'll see here that we actually have handles to move these out into different positions, but what we want to do is actually visualize these all together. So I'll go another one here. I'm just eyeballing it, I'm not doing a specific measurement. Add again, I'll do one here, and I'll do one right on the tip. And what you can notice straight away is the beginnings of what we talked about in class, wingtip vortex. It's also to do with the slight pitch of the wings. But yeah, you can see this kind of cyclonic kind of vortex type movement of air from the front. The air on top is being pushed in and down. The air underneath is being pushed out and eventually up. Yeah, so let's have a look at this from a different angle. So also one thing you would want to do is these are probably all set to pressure. So what are we actually visualizing here? So here we're looking at pressure. We want to look at velocity. And I think you can do that through here, edit as well. Static pressure, change to velocity magnitude. Okay, we'll look at that from the right-hand side. And we can just turn off all but one to do a bit more of a fine analysis here. So this is the one right on the wingtip. If you mouse over, you can see the direction of these lines here. You don't see too much of a change in air from this point here. But if we turn on another one, you can see definitely this top part of the aerofoil is really doing its job of pulling air down. But we actually don't see the underneath of the wing doing as much work. So that might, you can see here, this top section along here, you can definitely see it's trending down. But then this underneath section, it's kind of just a little bit neutral. That might be what we want. That might be creating the right amount of lift for our glider. We'll have to wait till we do our wall calculation and actually weigh this glider and compare it to how many newtons of gravity it is under. So, but here you see kind of more of a straight line. But this definitely, this section here, the resulting trend in air direction is certainly slightly down. If we choose another one, you can definitely see it happening here as well. There's definitely, it's very subtle to see, but if you look at that trending down, the air here is definitely changing in the way we want it to as a result. And other things you want to look for as well is you don't want to see too much of a change in air velocity. So if you notice too much of a change in air velocity, probably the highest we can see is around this area there, and that's associated with our drag as well. If I even put on our planes map, you'll see that it's kind of, displaying in similar fashion. Really, really cool stuff. So I'll turn off my planes and I'll keep looking through. And again, this is all just analysis. We're just looking at what we can see using these tools. And my analysis is at the moment that this is functioning fairly well. I don't know, I can't make a full judgment yet on whether it's viable for flight yet or not, because I don't have the data from wall calculation. Yep, so you can see here, right in towards the center of the glider, we're seeing a bit more of a slowdown of air, and that might be associated with the proximity to other structures and things like that. Interesting. Okay, so I don't really have the whole picture yet. I'm guessing that I'm kind of feeling that this will be successful in flight, but to reiterate on this, all I would really need to do do is change my angle of attack. All right, so I'm going to turn off traces completely. The last thing I want to do is go to my wall calculator, okay? So I'm going to turn, so everything should be turned on actually, and I'm going to go to wall calculator, and I'm going to go here and select volumes, and then I'm going to check in force. I'm going to change force down to newtons, okay? So you want to select volumes, and you want to change your force to newtons. Now, the objective with this process is to only focus on the glider as a volume, okay? So what we're going to do here is we're actually going to turn off air as a component here, and we are going to select all of our volumes because there's a whole bunch of different sections in our tail fin. There's a whole bunch of different tail fin volumes. We're going to select all of those. Okay, and here, now see what we've got here is everything in pink, highlighted in pink, is selected. So now what I'm going to do is uncheck that. Right, so what I want is this, all of my solid volumes selected and all of my fluid volumes deselected. Okay, once I have that, I can go to calculate. Okay, that hasn't worked the way I wanted it to. I need to actually check all of these. We'll see if that works. Okay, I'm going to start this one again. It hasn't worked for me. I'm going to turn off air, go to wall calculator, change force to newtons, change it to volumes, and I'm going to select the volumes I want. So you have to directly click there, the volumes that you want. So here's that. Tail fin 1, 2, and 3. Okay, that's pretty much everything selected. All right, now this is the proper way to do it, so I'll try and edit out that other bit there. Now here, with all those volumes selected, I want to go to calculate, and this is what I want to see. So the output file, you can go all the way to find the information you need, all the way down to the bottom. Okay, what we want is this summary section. Okay, you can write this to file, so we'll do that now. Go right to file, and we'll save that in our components. Sorry, in our root folder for this simulation, and we'll go simulation 1 data, and it saves as a CSV, which is a spreadsheet. Okay, we'll open that in a sec. But see what I have here. This is the really important data. So Fx, so force in the x direction, that is negligible. Okay, we're not looking at the kind of cross forces here. Fy, so total forces in the y direction, that is our drag and our wind resistance. And we can see that is 0.143 newtons. Now we go to our lift. Total force in the z direction is positive 0.347 newtons. Okay, and that's the really important data there. Okay, so let's go through and we'll go and calculate that using a spreadsheet, so you can actually get some really hard data on what to do there. So I will save this, and we'll go back to our original file. So for me, it is C drive, CAD, simulation there, and you can see my simulation 1 data file is there. Okay, so what I'll do now is I'll do a quick pause. I'll do a quick pause, and then I will quickly weigh my glider, and we'll do a comparison of that data there. Okay. Okay, so I've just gone away and weighed my glider quickly, and what I've come back with is 16 grams. So I'll open Excel. Just close that down. Okay, and as before, what I can actually do is just go down and select all of these all the way down to the bottom when I get to my summary. Okay, I can delete everything except for this summary part here. Okay, and I can take this data. I'm sure there's a better way to do this, but I'll take that. I'll go directly back to the top, and I'll just replace that. Probably do just shift cells up or something like that. So I'll go here. I'll paste that in. Okay, so total area. This does matter. That might be something you want to compare between different iterations. So the area of your wings does relate to how much lift you can produce. And we want to see these three things. So if I expand this here, Y, Z, X, Z. We won't worry so much about these. What we will focus on is this, okay? So let's have a look. I'll make this a little bit bigger. So if we're going off our formula here, so F equals MA. I'll make that a bit bigger for us. Okay, so if F equals MA, force equals mass times acceleration. That gives us our force in newtons. So we already have the resulting force in the Z direction here. So we've got 0.3475. Okay. What we need to calculate here is the weight of our glider versus gravity. So gravity, I'll turn all of these to bigger text so we can all see it. 20, awesome. So gravity will equal negative 9.81 meters a second. Okay, so that is an accelerating force downward. Okay, so we have our acceleration. Yeah, what we need now is our mass. So the mass of my glider, I'm going to do this in kilograms because whole newtons I will calculate in kilograms. So my mass, I'll put this in bracket A. So our mass here equals 16 grams, or in other words, it will equal 0.016 kilograms. Okay, so this gives us all the things that we need to actually run our formula. Okay, so F equals MA. Here I will run a calculation. So to do that, we go into our calculation field up here, equals. So F, so we'll get the result F here in newtons. Mass, which is, I'll just make the proper numerical values here. I made them nice and big for you to, negative 9.81, and here 0.016. Okay, and I'll go back here, equals F, so equals H4, which is 0.016, then times, which is a little star indicator, negative 9.81, and I just hit enter. Okay, so here, that is how many forces of gravity, so how much force in gravity in newtons I am generating, 0.015. And essentially what we want to be sure of is that we're generating more lift than we are negative gravity with the weight of our glider. Okay, wind resistance will factor in as well, but if I take this total force, and then I'll make this bigger as well. So this will be, so our total force will equal our Fz minus our total gravity, our total newtons of force of gravity. Okay, so, oh, sorry, we have to, that's an addition, not a minus. We have to add these forces together. There we go. So I'm generating positive 0.19 newtons of lift, okay? So what I'm seeing here is my glider should fly, and that's how I can see that it should fly. There might be other minor changes that I'll make to make it fly better. That could be decreasing or increasing the angle of attack, and obviously changing the position of the wings in order to create a balanced flight. We know from our worksheets that we need to create balance and equilibrium when we're testing our flights. Okay, so there you have it, everyone. We can go forward and finish up that lesson there. You should understand how to make those assessments of your gliders. So thanks, everyone, and I'll speak to you soon.